Number 22, write a statement that indicates that the triangles in each pair are congruent. Okay, so we want to write the congruent statement. Okay. The way I like to do it, I like to match up the arcs in each triangle. So the point with one arc on the triangle on the left is U, and the one on the right is T. And then two arcs would be on the left, it would be T, on the right, it would be U. And with three arcs on the left, it would be S, and on the right, it would be C. So UTS is congruent to triangle TUC. That is option A. Complete each congruent statement by naming the corresponding angle or side. So it's given that triangle SRQ is congruent to triangle SCA. So angle QSR is congruent to what angle? Okay, Q corresponds to A because it has three arcs. X corresponds with S, and R corresponds with C. So angle QSR is congruent to angle ASC, which is option A. Number 24, state if two triangles are congruent. If they are, how do you know? Okay, so here we see we have two pairs of angles. We have angle, angle, and also they share this side in the middle. So it's angle, angle, side, option D. Number 25, we have corresponding angles, corresponding sides, and also we have vertical angles here, so these angles are congruent. So we have angle, side angle. 26 and 27, sketch an example of the type of triangle described. Label the sides and angles with realistic measurements. If no triangle can be drawn, write not possible. Okay, obtuse scalene. So obtuse means it has to be greater than 180 degrees. And scalene means that all sides are different. So we need triangles that has at least one obtuse angle. So we could eliminate A and we could eliminate D because they don't have obtuse angles. Okay, and then all sides have to be different. So we could eliminate C. They have two sides are the same. So the answer would be A. It has an obtuse angle and then all sides are different. 27, right isosceles. So this one has to have a right angle. Isosceles needs to have two congruent sides. Okay, so we could eliminate option D because it doesn't have a right angle. A and B do. Okay, this is 90 degrees. And then two congruent sides. So A has two congruent sides and B has two congruent sides. So actually A and B work for number 27. 28, solve for X. Okay, we could see here that T is a midpoint and S is a midpoint. So that means that ST is a mid-segment. So since ST is a mid-segment, 2 times X plus 14, so 2 of those is equal to 21 plus X. So 2X plus 28 is 21 plus X. Subtract X on both sides. And then subtract 28 from both sides. So X is negative 7. Okay, similarly, number 29, B is a midpoint, A is a midpoint. So again, 2 times X plus 22 is equal to 32 plus X. If I distribute, I have 2X plus 44. subtract x from both sides, and then subtract 44 from both sides to get negative 12. All right, 30. We have a triangle, and we have the three angle measurements. All right, so solve for x. We want to use the triangle sum theorem. So that means the three angles add up to 180 degrees. So 55 plus 80 plus x plus 51 equals to 180. Okay. 55 plus 80 plus 51, I'm going to combine like terms. Should be 186. And if I subtract 186 from both sides, I get negative 6. Okay. For 31, I could see that this angle here is supplementary with the 117-degree angle. So this one has to be 63 degrees, all right? Because it makes a straight line. 117 plus 63 is 180. So again, we could use the triangle sum theorem to solve for x. So this time we have 63 plus 6x plus 4 plus 3x plus 5 is 180. Combine like terms, we have 9x plus 72 is 180. Subtract 72 from both sides, so 9x is 108. And then divide by 9 to get 12. State if the three numbers can be measures of sides of a triangle. So for this, we're going to use the triangle inequality theorem. That means that the two smaller sides has to be greater than the biggest side. So it's 6 plus 7 greater than. Yes. Okay. All right, next one, 32. Sorry for the number confusion here. So if triangle JKL is congruent to triangle MNO, which statement is always true? Okay. If it helps, you could draw out two congruent triangles. So if they call this JKL, make sure it corresponds MNO. Okay. So this, okay, make sure they correspond. So is KLJ congruent to NMO? So is this angle congruent to this angle? No, they're not in the same spot. Okay, so not one. Number two, KJL. So this angle, is that congruent to MON? No, they do not correspond. Is JL congruent to MO? Yes. And then we could check that JK and ON do not correspond. So the answer is actually number 3. In the diagram below, triangle ABC is congruent to triangle XYZ. So I'm gonna go ahead and mark it. So A corresponds to X, and then B corresponds to Y, and then C corresponds to Z. So which statement must be true? Is C congruent to Y? That's going to be no, it's not the same angle. Is A congruent to X? Yes, that one works. They have one arc. AC and YC, do not correspond, and BC and XZ do not correspond. Okay. 34, as shown in the diagram, AC bisects BAD and angle B is congruent to angle D. Which method can be used to prove that the triangles are congruent? Okay, so B is congruent to D. So I'm gonna go ahead and mark it. Okay, that's given. And then AC bisects BAD. So that means that two resulting angles are gonna be congruent. And also, since AC belongs to both sides, that's also congruent. So we could see that we have angle, side. It's going to be number 4. In triangle DEF, angle D is equal to 3x plus 5, angle E is equal to 4x minus 15, and angle F is equal to 2x plus 10. Which statement is true? Okay, so let's go ahead and draw this triangle out. D, E, F, 3x plus 5, 4x minus 15, and 2x plus 10. First thing I'm going to do is use the triangle sum theorem to find the value of x. So 3x plus 5 x minus 15 plus 2x plus 10 is equal to 180. Combine like terms. 3x plus 4x plus 2x is 9x. 5 minus 15 plus 10 is, I think that's 0. 5 minus 15 is negative 10 plus 10 is 0. Yeah, it's 0. So 9x is equal to 180. Divide both sides by 9, so x is 20. So if x is 20, let's plug it in for each angle and see what we get. 3 times 20 is 60, plus 5 is 65 degrees. 4 times 20 is 80, minus 15 is 65 degrees. 2 times 20 is 40, plus 10 is 50 degrees. Okay, so here we could see that E and D are both 65. Okay, E and D are both 65, so they're congruent to each other. But that's not one of our options. E and F are not the same, D and F are not the same. So how do we know if the sides are the same? Well, if the angles are the same, the sides opposite to them are also the same. So that means that EF is congruent to DF. Or, DF and FE are the same. So it's going to be option number 1. DF and FE. Number 36, given a triangle ABD, BC is the perpendicular bisector of AD. Which statement cannot always be proven? All right, so let's mark the perpendicular bisector. This is perpendicular bisector. So that means that this one and this one are the same. It's perpendicular and it bisects AD. Okay. So, and then we also know that BC, well, BC is congruent to itself. Okay. Now let's check. Is AC congruent to DC? Yes, that's true. We want to be looking for not. Is BC congruent to CD? That's the one that cannot always be proven. So BC doesn't necessarily have to be congruent to CD, because BD could be much longer. B could, yeah, BC could be much longer. Like it could be up here, right? And that's obviously not congruent. Okay, so that option is 2. Number 37, if triangle ABC is congruent to triangle JKL, which is congruent to RSC, then BC must be congruent to, so remember the letters correspond. BC are the second and third letter. So that's going to be congruent to KL and ST, because those are the last two letters. Remember, the order matters. So which one works? JL no, JK no, ST. ST is the one. Okay. 38, right? Some proofs. Given that ABCD is a parallelogram, a student wrote the proof below to show that a pair of its opposite angles are congruent. So we started with the given, and then BC is congruent to AD. We mark it. AB is congruent to DC, and then AC is congruent to CA. So the ones in the middle. And then, so that means that the triangles are congruent by side by side. So BD is congruent to, B is congruent to D. Well, since we already know that the triangles are congruent, then corresponding parts of congruent triangles are congruent. So this is going to be option C. You've seen this more often like this. CPCTC. So once you establish that triangles are the same, then any other corresponding parts are also congruent. Okay, that was 38. 39. In the diagram of the quadrilateral, ABCD, AB is parallel to CD. Angle ABC is congruent to CDA, and the diagonal AC is drawn. Which method can be used to prove triangle ABC is congruent to triangle CDA? Okay, so we have one angle. We also have the side here that are the same. Okay, another thing you could say is that this angle here, BAC, is congruent to angle DCA because we have parallel lines cut by a transversal. So alternate interior angles are congruent. So now we have angle, angle, side. Option 1. In the diagram below, triangle ABC is congruent to triangle XYZ. ABC is congruent to triangle XYZ. So I'm going to go ahead and mark it just in case. A is congruent to X, B is congruent to Y, and then C is congruent to Z. Which two statements identify corresponding congruent parts for these triangles? Oh, all right, so we have to check. So is AB congruent to XY? So so let's go ahead and mark them with the tick marks as well. Do this in red so you can see the difference. Okay, AB is the same as XY. BC is the same as YZ. And AC is the same as XZ. So ABXY, yes. What about C and Y? No, this one doesn't work. AB and YX, AB and YZ, no, that doesn't work. So we eliminate that. BC and XY. No, that does not work. BC and YZ, yes. And then A and X, yes. So the option is 4. Okay, both statements have to be true. 41. In the diagram below, 4 pairs of triangles are shown. Congruent corresponding parts are labeled in each pair. Using only the information given in the diagrams, which pair of triangles cannot be proven congruent? Cannot. Okay, so let's see. Option A gives us side, side, angle. But remember that side, side, angle or angle, side, side does not prove congruence. So it's most likely going to be A. And let's just verify the rest. C gives us angle, angle, side. You use that to prove triangles are congruent. B gives us angle, side, angle. That works. And then D gives us the hypotenuse and the leg HL. Yeah, so A would be the one that doesn't work. 42. Supply the regions missing from the proof shown below. All right, so it's given that AB is congruent to AC, and then angle BAD is congruent to angle CAD. Okay, it's marked already. We want to prove that AD bisects BC. Okay. So we started with the given, and then the reflexive property says that AD is congruent to itself. That's step 3. Step 4, we have enough information to show that the triangles are congruent. BAD is congruent to CAD by side, angle, side. And BD, so now we've proven that the triangles are congruent. So BD has to be congruent to CD because corresponding parts of congruent triangles are congruent. And then step 6, AD bisects BC because of the definition of segment bisector. So option D is our answer. Okay, 43. M is the midpoint of CF. For the points given, find MF. So MF is the midpoint. M is the midpoint. So MF would be half of CF. So let's find the distance between C and F, and then we'll just divide it by 2. Okay, so CF is equal to the square root. So this is x1, y1, x2, y2. I'm going to subtract the x's, 9 minus 3 squared. Subtract the y's, 8 minus 4 squared. 6 squared plus 4 squared is 36 plus 16, which is 52. So square root of 52 is the distance between C and F. Now we're going to divide that by 2 to get MF. Okay, but you know what? I'm going to simplify the square root of 52 first. Square root of 52 is the same thing as square root of 4 times the square root of 13, which is 2 square root of 13. Okay. Then MF is 2 square root of 13 divided by 2, so it's just square root of 13. 44, angle DFG and angle JKL are complementary angles, so they add up to 90 degrees. DFG is x plus 5, JKL is x minus 9. Find the measurement of each angle. So let's solve for x first. So we know that x plus 5 plus x minus 9 has to equal to 90 since they're complementary. So 2x minus 4 is equal to 94. I'm sorry, 90. Add 4 to both sides. 2x is 94. And then divide by 2. So x is 47. X is 47. So 47 plus 5 is 52 degrees. 47 minus 9 is 38 degrees. Sorry. So DFG is 52 and JKL is 38. Option C. I mean, option D. I'm sorry, option D. And then 45. Which plane is parallel to plane EFHG? EFHG is the plane over here in the bottom. Okay, that's the bottom of this box. So the parallel one would be the one on top of the box, which is up here. A, B, C, D, which is option A.